Alright, today we're going to take a look at the quotient rule. You'll notice that I've actually filled in quite a bit of the information already, because this is my second time through, because I messed up the video the first time. So anyway, first of all, I want to call your attention to the product rule that we learned last time. So if you have a function that is a product of two different functions, then the derivative would be the derivative of the first function times the second function plus the first function times the derivative of the second function. So right now what I want you to do is I want you to use this knowledge and your vast knowledge of algebra to attempt to come up with the quotient rule. So when you have a function that's built up of a quotient of two other functions. Okay? All right. So, this is what I hope you found. If you didn't, don't worry too much about it. It is a rather complicated one. But here we go. So, if we have h of x, which is a quotient of f of x and g of x, then this is going to be our formula for the derivative of h of x. We have f prime of x times g of x minus f of x times g prime of x. And the top obviously looks very similar to the product rule, but then we have to divide the entire thing by g of x squared. It is important to note it, or to mention that there is obviously a restriction on this one. For this, g of x cannot equal 0. Okay? All right. So example number 1 here, we're going to find the derivative of the function f of x, which is equal to 3x minus 5 over 2x plus 6. So first of all, you'll see we've got, so we're taking the derivative of the top of the function times the bottom of the function minus the top of the function times the derivative of the bottom, and then we have to square the bottom. Now you'll notice that I do not expand the bottom of the function. There is no reason to expand it most of the time, and so if you do end up expanding it, you're going to want to wait till the very end to make sure, because you probably don't have to do it anyway. So anyway, so I took the derivative of 3x minus 5 and got 3. I multiply by the 2x plus 6. Then I take 3x minus 5 and I multiply by the derivative of 2x plus 6, which is 2. And then we just divide by the 2x plus 6 squared. So I can expand a little bit here. Not a lot, but a little bit. The 6x's will cancel out, and you're left with 28 over 2x plus 6 squared. Okay? All right, so I do want you to go back to your last lesson and just compare your answer there from 1A. Nope, from 2.3, or what is it? Example 4, there you go, example 4. Compare it to example 4. All right, so let's jump over to the next one. So I'm going to just go over the middle one here, and I'm just going to let you do the other two on your own, because there's quite a bit here. Okay, so anyway, so again, we've got the top, we've got the bottom. So we take the derivative of the top, okay, and we multiply it by the bottom. You then subtract the top by the derivative of the bottom, and then we divide by the bottom squared. Okay. Now, this says do not simplify. I did kind of simplify that top there. You don't actually have to do that if it says do not simplify. Realistically, this guy is pretty much enough. Okay, right here. Anyway, so let's jump ahead to one that's a little bit more complicated. So this is one where I say find the equation of the line tangent to the function at x minus 1. So there's a couple of extra things we have to do here. So to begin with, we're going to find the derivative. So the derivative is fairly simple. They're fairly straightforward, although these ones do get a little messy with the algebra. Okay. But you can see, again, just like before, I'll do it this way. And we got the top, we got the bottom. So we take the derivative of the top, multiply it by the bottom, we subtract the top times the derivative of the bottom. Okay? And then we've just got the bottom squared. So once we've done that, what we're going to find is the slope. We're interested in the point at x equals -1, so we can find f prime of -1 by subbing -1 into the original function here. So we've got f prime of -1. Okay, and we find that it equals -5. So the other thing that we then have to do is we have to find out what f of -1 is, not the derivative. So we use the original function here. Okay, we're looking right here. We use the original function, we sub in x equals -1, and we find that the y value would be equal to +1. Okay? So once we've done that, we found our slope. So our slope was -5, so we've got y equals -5x plus b. And we sub in the point -1, 1, which will allow us to find that b equals -4. So our equation is y equals -5x minus 4. All right, so I got halfway through this next one before I had technical problems. But so what I've done here, so this next one, first of all, before we start, so we're looking for the tangent line that is horizontal. So I haven't told you where it is. I want to find out where it is. Okay. So what you have to remember is that if we have a horizontal tangent line, then that means the slope is 0. So that means that the derivative of the function will be 0. Okay? The derivative will be 0 at this point. So what I've done, so to begin with, I've found the derivative. Okay. And again, you can see we've got a top, we've got a bottom. Now you can see I changed the top from root x into x to 1/2 so that we can use our power rules. But we've got the derivative of the top times the bottom minus the top times the derivative of the bottom. And then we've got the bottom squared. So now that we've got that, what we're going to do, because we are looking for the horizontal tangent, we're going to say, let's let g prime of x equal 0. So we have 0 equals, and then we just have the same thing. So we have 1/2 x to the -1/2 times 1 plus 2x minus x to the 1/2 times 2. Oh, and then I got to divide by 1 plus 2x squared. So the trick here is that if I know this whole thing, here equals 0, then what I know is that the top equals 0. Now it is worth mentioning, before we go any further, that I probably should have at the top stated the restriction that x is going to be greater than 0. Because of course if you're taking the square root of x, x has to be greater than 0. Now the bottom would have the restriction that x has to equal, or can't equal -1/2, but that doesn't matter because it has to be greater than 0 anyway. So obviously it can't equal that. So anyway, so if we've got a fraction equal to 0, we know that the top equals 0. So we can actually ignore the bottom. So we can just replace this, and I'm going to simplify a little bit as I go. I'm going to say that 0 equals, and so we just, here, let's make a note. Ignore. Okay. And what we'll have is we're going to have, and I'm going to take this guy right here, and I'm going to rewrite it a little bit because I've got a negative exponent. So I'm actually going to rewrite that as a denominator of 2x to the 1/2. Okay? And then I'm going to take all this, and I'm going to put that on the top. Okay, because it's being multiplied by it. So 1 plus 2x. And you'll see why in a few minutes. This is really going to simplify things for us. So minus 2x to the 1/2. Now, the other thing that I'm going to do, I'm going to rewrite this again, and we no longer need these exponents of 1/2. I'm going to rewrite them as, so I've got 1 plus 2x, and I'm going to write that as 2 root x minus 2 root x. Okay, the reason we did that was for taking the derivative, and that's done now. So I'm going to do that just for simplicity. So now what I have to do, I mean, there's other ways you can do this, but I think that for me the simplest thing to do is I'm going to put this over a common denominator. So what I'm going to do is I'm going to multiply this by 2 root x, sorry, over 2 root x. I'm just multiplying the second term by that, and what that's going to do is give me a common denominator of 2 root x. So I'm going to just pick it up over here, and we're going to have 0 equals 1 plus 2x over, actually I'm going to do this. I'm going to do more steps than I would necessarily. Hold on, let's rewrite this. 1 plus 2x over 2 root x. Okay, and then it's minus, let me just look back, and I will have 4x. You can see I'll have it 2 root x times 2 root x is going to be 4x. 4x over 2 root x. So now I can just zoom in again. I can put this over one denominator then. I can have 1 plus 2x minus 4x equals, or over 2 root x. So we get 0 equals 1 minus 2x now over 2 root x. Now, again, I've got a fraction equal to 0. If I've got a fraction equals 0, we can just ignore the bottom again. Ignore. I probably should have made my pen a little skinnier for that, but whatever. Because, again, if you've got a fraction equal to 0, the top has to equal 0. So I have that 0 equals 1 minus 2x, which gives us that x equals 1/2. And so that's going to be our answer. Because I think that's what it asked. It said, where was the tangent horizontal? Well, it's horizontal at x equals 1/2. Okay, there we go. All right, so there's one more question that I do want you to do by yourself, and then we're going to begin the next class with that question. All right, so until next time, go Sabres.